All right, guys, now we're on to 3-9, proving lines parallel. We're going to use some of the information we've done from these last couple classes. It might be slope, might be a lot of the, as you can see on the page right here, corresponding, alternate interior, alternate exterior, consecutive, or same side interior, consecutive, same side exterior. We're going to look at all those, make sure that we can tell whether things are parallel or not. So, learning intention for the day, I'm learning how to use angle relationships, so things we did, I think, back in 3-7, perhaps, maybe 3-6, and logical reasoning to prove that lines are parallel. Success criteria, I can explain the concept of parallel lines and transversals and identify the different types of angles formed. That goes back to that last chapter, again, showing all these things right here. You can look at lines and figure out, okay, 1 and 5, those are corresponding. 4 and 6, those are alternate, things like that. That's what that success criteria is talking about. I can use appropriate definitions, postulates, and theorems to support proofs. That, again, goes along with this little chart right here that we've done on other pages. And then I can apply those properties of parallel lines and transversals to find missing angle measures. Again, similar things here to that last couple sections ago, but now we're actually using it in somewhat proofs. It's not a full proof, it's just showing, are those angles supposed to be equal? Are they supposed to add to 180? How does it work? Okay? So, let's take a look at this first little chart right here and kind of fill this in a little bit. For each of these, there could be 4 different examples. I'm just going to do one of them. We've done these. Hopefully we can get them done. All right? So, corresponding angles converse. If 2 lines are cut by a transversal so that a pair of corresponding angles are congruent, then the lines are parallel. So what they're asking us to do here for this example is actually give a set of corresponding angles to tell whether the lines are congruent or not. And we're going to do it in an if-then statement just like they did. So if, and write down a pair of corresponding angles. Again, I gave the example of 1 and 5. So I'm going to say if angle 1 is congruent to angle 5, which we say that corresponding angles should be congruent, then line L should be parallel to line M. That's all we're doing for this, is we're going to give an example of whatever this is, corresponding, alternate interior, alternate exterior, consecutive, all that good stuff, and putting it in an if-then statement like we did earlier in the chapter. So what I need you to do is write down an alternate interior angle. Which ones are alternate interiors? Well, they got to be on opposite sides of the line. They have to be inside, so that leaves us with only these 4 angles, 3, 4, 5, and 6. So opposite sides, inside, and they don't touch. They're not adjacent. So I'm going to say if angle 4 is congruent to angle 6, that's what we said about alternate interiors, that they should be congruent if the lines are parallel. So we're writing the opposite of that. We're writing the converse. If angle 4 is congruent to angle 6, then line L is parallel to line M, just like the one above it. We're just putting this big old paragraph, or it's not a paragraph, it's a sentence, but looks like a paragraph, into a more reasonable looking sentence. Alternate exterior. What are 2 angles that are alternate exteriors? Well, again, it's got to be outside, so 1, 2, 7, 8, and they got to be on opposite sides of the line. So if I can write an I, if I'm going to say angle, I used angle 1 before, so let's say angle 2 is congruent to angle 8, then the lines are parallel. L is parallel to M. Those were the three that were supposed to be congruent. For the consecutive interior and consecutive exterior, those were supposed to be supplementary. Again, up here we had congruent, 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 supplementary, supplementary. What does supplementary mean? It means two angles add to 180. So this one is going to say if consecutive interior. So again, 3, 4, 5, 6, they need to be on the same side. So I haven't used a 3 yet. Let's give 3 a little love here. So if angle 3 plus angle 6 equals 180 degrees, then the lines are parallel. L is parallel to M. If you want to be technical right now, if you want to write things exactly correct, it's going to be hard, I know, it's a small box. It should say measure of angle 3 and measure of angle 6. It's not the worst thing in the world, but on a test, it will mark you wrong if you don't put that M, so I'm going to make sure that I do you guys right here. Now we're doing the same thing for consecutive exteriors, just now instead of inside, it's outside. I don't care which angles you use. If the measure of angle, at this point I think I've used everything, or just about. What number haven't I used? 1, 2, 3, 4, 5, 6. I haven't used 7 yet, so let's figure out 7. The angle that is a consecutive exterior angle, that's 2, so the measure of angle 2 plus the measure of angle 7 should equal 180 degrees. Because of that, so if the measure of angle 2 plus the measure of angle 7 equals 180, then L is parallel to M. Just examples of each 4 of those so that as we go farther in, we can get some work done. Now let's look at these first set of problems here, these first 6. Determine if lines L and M are parallel based on the information given in the diagram. If yes, state which one of these proves the lines are parallel. I'm going to give you a quick hint. If your two angles are both on the same line in terms of the parallel line, you can't prove anything. Doesn't mean that the other ones are all right, but you just can't prove anything if they're on the same one. So like how this one, number 1. I'm not even going to go through this yet. I'm just going to look at something quick. This top angle is on the top parallel line. This bottom angle is on the bottom parallel line. We can do something with that. Whether it's right or wrong, we don't know yet. This one here, we have an angle on the top line, angle on the bottom line. I'm not talking about the transversal. They're all going to be on the transversal. Okay? Here we have one on this parallel line, one on this parallel line. Number 4, we got nothing on line L. So immediately, we are able to say, we can't do this. That's a no. We cannot prove that these lines are parallel because they are on the same parallel line. And we have one on L, one on M, one on L, one on M, one on L, one on M. This one, they were both on M. One on L, one on M, one on L, one on M. So we can do the other 5, but number 4 was just immediate no. So again, you're going to be able to see the numbers on your paper. You probably can't see them on your computer screen right now, but that's why you have the 2 forms. You have the digital and you have the paper-based. All right. So what kind of angles? I don't care about the number right now. What kind of angles are these? They are on opposite sides, which means alternate. So it's going to be one of these 2. Are they inside or outside? They're inside. So if this is true and these are parallel, then these should be congruent. Well, are they congruent? Yes. How do we know? Alternate exterior. So that's all we're going to do. I want you to try this. Try these other 4. All Right? Tell me if it's corresponding, alternate interior, alternate exterior, consecutive interior, consecutive exterior, and whether it's a true statement or not. Right? Give this a shot, pause the video, try these, and we'll see what happens. All right? All right, how'd you do? Hopefully, you were able to say for number 2, yes, because they're corresponding. Number 3, yes, they are consecutive exteriors. They're on the same side of the transversal, and they add to 180. Number 5, yes, alternate interior. They're the same. Number 6, they are consecutive interiors, but they do not add to 180. That's how they're going to try and trick you. They're going to give you the information that looks right, but the numbers aren't going to add up. Okay? So, how about number 7 and 8? I'm going to do 7, you do 8. So let's get to this. We got to figure out what kind of angles are these. Are they corresponding, alternate interior, alternate exterior, consecutive interiors, consecutive interior, or consecutive exterior? So are they going to add to 180, or are they going to be congruent? That's your job right now. All right? Well, they're on opposite sides of the transversal, so that tells me alternate, and it's on the inside, so alternate interior, which means they're going to be congruent. So I'm able to say 6x plus 4 is equal to 8x minus 8. I got to solve this, because all we're asked for is to find the value of x. I don't have to find the angle measure, just have to solve for x. So I'm going to move the smaller variable, so I'm going to subtract 6x. That way that cancels. I move my x to the right, so I'm going to move my numbers to the left. That way that cancels. 4 plus 8 is 12. 8 minus 6 is 2. Divide by 2. X is 6. Now I want you to try number 8. Give that one a shot. Good luck. Did you get x equals 13? If you set them equal to each other, I know you didn't. But if you added them together and set them equal to 180, then hopefully if you did your math right, you got it right because they were consecutive exteriors. Alternates are congruent. Consecutive adds to 180. Corresponding is the only one that's kind of throws that off, but that one's congruent as well. Okay. Again, that's it for this section. Okay. All we're doing here is we're either setting things equal to each other or adding them together and setting them equal to 180. That's this entire section. Good luck. If you have questions, send me a message. Good job.